Okay, so here we go. This is my second attempt on this because for some reason it didn't record my audio last time. All right, so today just going to look at natural logarithms. The natural logarithm is just a special logarithm. It's a special one that we do. Just to review, what a logarithm is this is asking us what power do I need to make 2 into 4? That's what a logarithm asks us. So basically 2 to the x equals 4, right? So in order to solve a problem that has a variable in the exponent, we have to use a logarithm to undo that. Obviously, we could also use graphical means or whatever. Now, what the natural log is the log in base e of something is equal to x. The only thing that we are changing is now this is saying what power do I need to make e equal 2. All right. Now, the thing with the natural log is it's such an important thing that we don't write it as log in base e of 2. It's so important that it gets its own symbol. And the way that we write this is ln of 2. I sometimes pronounce it ln, but it's ln of 2. So we don't use this form. Instead, we just write it like that, okay? And just so we can see that, if I take my calculator and I do control and I go to the e of the x, you can see that's where my ln is. And the natural log of 2 is that. And what that means is if I take e and I raise it to that power, I'll get 2. That's all that the natural log is doing for us. Now, it's a logarithm. So because it's a logarithm, all of our logarithm rules are still intact. If I add 2, I multiply inside. If I subtract 2, I use division inside. And if I raise something inside a logarithm to a power, it's the same as multiplying by that logarithm. Okay? So, on to the next idea. If we are solving something like this, financial applications, we can always just use our financial solver. That's one approach to this. As I said, I've already done this video twice now, and so I've already entered my data in and I've got my answer. So if I want to know how long it takes me to go from 200 to get to 300 with 12 compounding periods per year at 10%, I put my 10% in. I put my present value in as a negative, my future value in. I think in the question I said 300, and then when I wrote this down, I wrote it as 3,000. Good one, Stoltz. Um, and then here I would keep going down, and my compounding periods per year needs to be 12. And when I press enter, this gives me, it takes about 4.07 years. So 4 years and a little itty bitty bit. Okay. That's how we can solve it using technology. Technology is great, but a lot of times, or especially in this course or in more advanced mathematics, we want to be able to solve analytically, which means algebra. So that's what we're going to do. We're going to try to solve this using an analytic method. Okay, so analytic method is going to be just making sure I am still connected. I am. All right, this should work. The analytic method is going to be, we're going to use our formula for compound interest. So the compound interest formula is, would be my future value is going to be my present value times 1 plus my interest rate divided by 100 times the compounding periods, like that. Formula will be on any assessment you take, so you don't have to memorize it, but that's what it is. Now, our goal here is always, we want to isolate the exponential. We want to make it so only the exponential's on one side. In this case, that's pretty straightforward. We end up with 300 over 200 is the same as 1 plus 10 over 1200 to the 12n. Okay? Now that we're here, what I'm going to do, and because we're dealing with the natural log, I'm just going to take the natural log of both sides. And the reason for that is I can, so long as I do it to the same thing to both sides, I get equality. So the natural log of 3/2 is equal to, now here I'm going to use my log laws, and I'm going to pop that out front, so I get 12n times the natural log of 1 plus 10 over 1200. And now from here, I want to know what n is. N is currently being multiplied both by 12 and by that natural log. So to get it on the other side, I just need to divide by 12 times the natural log of 1 plus 10 over 1200. And that will give me what n is. And from here, I can just plug that into my calculator. And if we've done it right, we're going to get that 4.7 whatever. That 4.0715. All right, so I need to back out of here, and then I'm just going to do the natural log of 3/2, and then I'm going to divide that by 12 times the natural log of 1 plus 10 over 1200. Just making sure I got all my parentheses in. And of course, that looks just like what I had set up there. So I'm happy with that, but I do want the decimal answer. So I'll just add a decimal into my values, and I get that 4.0715. So this is just another way of approaching it. This is the more advanced analytical way. This is what I'm expecting of you in order to get a 6. Now, I hope that that is helpful.